We're looking at Chem 6, changes in matter, and we're going to be talking about chemical changes. We're focusing on different types of chemical changes so you can see some different examples. So this first one is the image on the right. This is a sterling silver goblet, and you can see that it has silver color, but once it has tarnished, it has this brown-black sort of coloration on it. So that is a film of tarnishing that has developed on top of this sterling silver. So in order to make that become silver again, a special cloth or cleaner is used, and that reaction will remove that particular film that has developed. Another term you may not be familiar with is electrolysis. So if you use your stems, electro refers to electricity, lys refers to break down. So this is using a current in order to break down a water molecule, for example. So you can see that these different electrodes here that are represented by the yellow color, those are going to separate the water molecule, the H2O, into hydrogen atoms and oxygen atoms. So the hydrogen atoms are going to be attracted to this side, and that's what's represented by the red, and the oxygen atoms are represented by the blue, so they're attracted to this side. So by running that current through this particular solution, it will split apart. It lyses, L-Y-S. It breaks apart that water molecule. So remember that a chemical change is going to be a change that occurs that produces one or more new substance. So something new develops as a result of this particular reaction. Combustion is one that you're probably familiar with. So that could be from burning wood at a campfire, or it could be the combustion process that happens in the engine of a car, for example. Electrolysis, we just looked at, splitting apart water molecules. Oxidation is another one. So another term for oxidation is rusting. So anytime you see rusting, it's referring to oxidation, which is chemical change. And then tarnishing is the other one that we just looked at the image of. So tarnishing brass, for example, tarnishing sterling silver. So those are all examples of chemical changes that can occur. So remember, those aren't all the chemical changes, but those are some common ones you may be familiar with. So a physical change. Remember that a physical change is going to be a change that occurs that does not develop anything new. It doesn't create a new substance, but it just modifies the appearance of the particular matter that you're looking at. So if you take this soda can, for example, this one on the left, this image shows some soda cans that have been crushed. So the soda can started out originally as tall, normal size soda can, and then after it was emptied, then it was crushed. And we've all probably done that at some point, stepped on the soda can, or some of you may have even tried to smash the soda can against a table or your head. Unfortunately, don't try that. So physical changes just change the matter and do not develop anything new. It just changes the appearance. So when we're looking at chemical changes, there are two different changes that can occur that relate to temperature specifically. That's endothermic and exothermic. So the stem therm refers to heat, endo refers to within, exo is out or outside. So an endothermic change is going to be a change where energy is taken in, and as a result of an endothermic change, the substance that is reacting is going to feel colder. So in a lot of sports or in first aid kits, a lot of times you will have these cold packs. So this cold pack, when you shake it, it will mix up the substances that are in that cold pack, and it will feel cold to the touch. And ice melting, so ice melting is just a physical change, but the sensation of the coldness is just something to keep in mind. So ice melting is not a chemical change, it's just that melting is a physical change, so don't get that mixed up. And then exothermic change. So an exothermic change is going to be where heat is released. It feels hot to the touch. If you've ever used these hand warmers, it's a similar process to the cold packs. It just contains different chemicals. So when you mix these hot hands, these hand warmers up, then they will give off heat. It feels warmer. Another example is fireworks, and then also candles. So when you light a candle, it gives off heat. Same thing with a campfire. As you're burning wood, it releases heat. So the law of conservation of matter is going to apply to chemical reactions. It's going to apply to any chemical equation, chemical formula, changes that we are talking about. So law of conservation of mass says that matter cannot be created or destroyed. It can change form, physical changes can occur, but matter is not going to disappear or suddenly appear out of nowhere. So let's take a look at this example. So in this example, we're starting out with one methane molecule, that's CH4. So we have one carbon and 4 hydrogen atoms. And then we also have two diatomic oxygen molecules. So we have a total of 4 oxygen atoms. So we can expect that in our products, we would end up with the same amount of those atoms. So if we add heat and combustion occurs in this particular reaction, we're going to end up with carbon dioxide and 2 water molecules. So in looking at this chemical equation, we need to have the same amount of atoms that we had for each element in the reactants represented in our product. So let's count and make sure we have the correct amount. So we have 1 carbon in the products, we have 1 carbon in the reactants. We have 4 oxygen atoms in our products, 4 in our reactants, and 4 hydrogen atoms in our products, 4 hydrogen atoms in our reactants. So an equation, a chemical equation that is balanced, will accurately satisfy the law of conservation of matter. It accurately represents that matter has not magically appeared, matter has not disappeared, but matter, these atoms, can rearrange as a result of the chemical process that is taking place through that reaction.